Okay, and welcome to video number 2. In the first video, we showed you what SSL strip is, how it works, and a few ways to deter and defend against it. Now in video 2 here, I'm going to be showing you how you can set it up and actually conduct the SSL strip attack on a target computer using Backtrack 4. So what do we need to use SSL strip? Well, we need an internet connection, a victim computer or target machine on the same subnet as the machine that we're going to be conducting the attack from. And then we need SSL strip, ARP spoof, and EtherCap. Now, SSL strip, ARP spoof, and EtherCap, all of these come pre-installed and ready to go on Backtrack 4. If you were to use a different Linux distro, you would need to download these and install them. But Backtrack 4 has everything ready to go. We're going to show you how to use it. So, what's the setup we have here? Well, we have a Windows 7 machine here, which is going to be our victim. We have Backtrack 4, which is where we're going to be conducting the attack from, and both these are running inside VirtualBox. So let's get started setting up SSL strip and Backtrack 4. The first step is to launch a console. Now we're going to be putting the machine into forwarding mode with this command. So that basically turns our machine into a router. So it's going to take in the HTTP packets and forward it out to the default gateway. Now the next step is we're going to set up IP tables to intercept all the HTTP requests, like this. Alright, once that's set up, you can close that console. Now we're going to have to find a machine that we want to attack on the same subnet as our machine. And we can check our subnet by typing ifconfig. And there we go. This tells us what our IP address is, in this case .10, and we can get our subnet from that. Now the next step is to scan the network for a machine we want to attack. Now we can do that with Nmap from the console here, but I prefer using ZenMap, which is a GUI front end for Nmap. So we just go into Backtrack here, network mapping, port scanning, and find ZenMap. Takes a second to start up here. There we go. We got ZenMap here. Now to scan the entire network, we put in our subnet. 1.254. And we don't want an intense scan. We want to do a quick scan. Hit scan. Okay. Now what a quick scan does is basically an IP scan, and then it checks the common ports to see which ones are open on each machine. Alright, so here we go right here. 192.168.1.7, that's the machine we want to attack. Now let's head back over to our client we're going to be attacking real quick. Make sure that matches the good old IP config. And there we go, .7. So we know which machine we want to attack. So we can close out of ZenMap. Close that. Now we want to set up the ARP spoof attack to poison the ARP table of the target machine. We do so as such. Now we want to do the target machine. In this case .7, and then the default gateway or default router. Now before we initiate this ARP poisoning, let's take a look at the ARP table on the client machine here. Okay, there we go. We have the ARP table here. Now right now it thinks the default gateway has this MAC address, which it actually does, but we're going to trick it into thinking that it has the MAC address of our machine right here. So let's go back in the backtrack and initiate the ARP spoof ARP poisoning. Just hit enter, and there we go. Now if we look back here on the ARP table again, now we can see that it now thinks that the default gateway's MAC address is actually ours. So all information bound for the internet is going to be routed through our machine here. So that's all set. Now the next step is to actually set up and run SSL strip like this. Port 1000, just hit enter. Just want to keep this window running here. Now what I'll note about the ARP spoof is we want to keep this window open. So we close it down, it will stop the ARP poisoning, and the client machine will revert back to the old MAC address of the default gateway, and we don't want that. So we just keep this window open here, let it keep running the ARP poisoning. Same with the SSL strip window here, just leave it open. Now the final step is to set up EtherCap, like so. Okay, there we go. We got EtherCap set up. Now the EtherCap window here is what we want to be focusing on. When the victim machine makes HTTP requests for the username and password to sites such as Facebook, Gmail, Yahoo Mail, those username and passwords are going to pop up here. So let's go. So now we have SSL strip, EtherCap, the ARP poisoning, everything's running here on our attack machine, backtrack 4. We're actually conducting the attack now. So let's see what happens on the client machine here when we go to try to log in. All right, let's start with Facebook. We'll use test123 as the username and test456 as the password. All right. Now let's try Yahoo Mail. Once again, test123, test456. Let's try PayPal. It's test123 at test.com, then test456. Now finally, let's go ahead and try Gmail. Test123 and test456. Let's try that one too. Alright, so we tried logging into all these websites with our username and password, and we noticed that it was always in HTTP, not HTTPS, so we know the SSL strip was working. Now let's look back on the attacker's machine on the EtherCap window and see what we got. And there we go. We got the username and password for Yahoo, the username and password for PayPal, and the username and password for Gmail. Not quite sure what happened to Facebook. Let's try Facebook one more time. Let's try test123, test456. See if it worked now. Okay, there we go. Not sure what happened there, but we finally got it. So there we go. That's how we use SSL strip to capture the username and password information from the victim. So if you want to find out more about SSL strip, how it works, a little bit more in depth, and some ways you can deter and defend against it, check back at video number 1 on SSL strip. Alright, thanks.